Hey guys, today we're going to go over adding fractions. So we have an example here, 4/9 plus 1/9. If you're looking at this fraction, you can kind of see right off the bat that we have a common denominator. So that's really key. So if you have a common denominator, and our denominator is 9, it's super simple. All you do is add the numerators. So 4 plus 1 is 5, and your denominator stays the same. Just carries over. It's 9. Of course, you want to try to simplify it if you can, but in this case we can't, so this is our answer. So if your denominators are the same, all you do is add the numerators. Let's look at another example. We have 3/4 plus 3/4 again plus 1/4. Okay, again, we have a common denominator, which is great. 4, 4, 4. So we are good. So all we do is we add our numerators. So 3 plus 3 is 6, plus 1 is 7/4. This is an improper fraction, so we can't leave it like that. We are going to have to simplify this by dividing. 4 into 7. 4 goes into 7 once. 4 times 1 is 4. 3 left over. Okay, ice cream cone. Our answer is 1/3/4. Okay, and then if you don't understand what I just did with the ice cream cone, watch my video on division. Okay, so your answer is 1 3/4. So let's look at an example where we do not have common denominators. We have 1/8 plus 3/4. So right off the bat, you can see we have different denominators. We have an 8 here and a 4 here. So we have to somehow make them common. How do we make them common? Well, we need to find the LCM, or the least common multiple. So we need to find a number that 8 can multiply into and 4 can multiply into. Okay, so let's look at the multiples of 4. So multiples of 4. Well, 4 times 1 is 4, right? 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. Okay. Now let's look at the multiples of 8. And these are the multiples, right? These are the factors. We're not looking at these. We're looking at the multiples. Now, multiples of 8. Well, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Okay, let's look at the multiples of 8. I just only listed a couple. So you probably can already see it. What's the least one they have in common? The smallest one they have in common? Well, it's 8. So that is going to be our LCM. Okay, so I'm going to rewrite the fractions with 8 as my denominator, and then I'm going to convert. What did I multiply 8 by to get to 8? Well, I just multiplied by 1, so that's not going to change, right? So my numerator here is 1 still. What did I multiply 4 by to get to 8? Well, I multiplied by 2. So my numerator here is 6. Then I solve like I did with the other examples. Once I have a common denominator, which I do, I just add my numerator. So 6 plus 1 is 7 all over 8. If I need to simplify, I simplify, but in this case, I can't, so that's my final answer. Okay, so that's how you would add using the LCM method with different denominators. So let's look at mixed numbers now. Well, what do we do with mixed numbers? So we have 3 3/4 plus 2 5/12. Okay, so there's a couple ways you can do this. I'm going to show you, I don't want to say ways, but looks, okay? There's different looks to this, and you can decide which look you prefer, okay? So first I'm going to solve this horizontally, and then I'm going to show you vertically, and you can decide which way you prefer. The method is the same, but the visual is different. Okay, some people prefer it one way, some people prefer it the other way. So one thing I noticed right off the bat, I have different denominators. So I need to fix that. I need to find an LCM between 4 and 12. And I always like to check with the biggest number to see, can the small number multiply into that biggest number? Can that biggest number be the LCM? Well, can 4 multiply into 12? It sure can. 4 times 3 goes into 12. So 12 is our LCM. So always check with the biggest number to see if that one will work. Now your whole numbers always stay the same. They never change when we're adding. Okay, they'll change when we're subtracting, but when we're converting, okay, our answer is going to change, obviously, right? But when we're converting, they don't change. They remain the same in the conversion process, okay? Same with subtracting. They remain the same in the conversion process unless we have to borrow, but we'll get to that later. Don't worry about that. Okay. All right, so we have 12. Now we need to start converting. What did I multiply 4 by to get to 12? Well, I multiplied by 3. So my new numerator is 9. What did I multiply 12 by to get to 12? 1. So my numerator here remains 5. Next, what I'm going to do is just add my whole numbers. So 3 plus 2 is 5. Okay. Remember, denominator stays the same, just carries over. And then 9 plus 5 is 14. All right, what do you notice about this? Improper, right? So let's convert it. Can't leave it like that. We need to divide. 12 goes into 14 once. 12 times 1 is 12. 2 left over. Ice cream scoop. 1 stop, 2 stops, 3 stops. So this becomes 1 and 2/12, right? Right? Okay, but we still have that 5 here. So what are we going to do? We're going to add them together. So 5 plus 1 is 6 and 2/12. Okay? That is our final. Now, again, we need to ask, can we simplify this? We always kind of have to be asking this while we're solving fractions. And in this case, yeah, we can simplify 2/12, right? We can take both of these down, divide both by 2. So then this becomes 6. Whole number stays the same. 2 divided by 2 is 1. 12 divided by 2 is 6. 6 and 1/6 is your final answer. Okay, so how do we tackle mixed fractions? We find the LCM like we did with the regular fractions. We convert them, bring the whole numbers down, right? Once you've converted the fractions, you add the whole numbers. 3 plus 2 is 5. Add the numerators. 9 plus 5 is 14. Denominator stays the same. If it's improper, in this case, we still divide it out. When we get 1 and 2/12, you see we are left with a whole number right here. We add that whole number to the original whole number of 5. So we get 6 and 2/12. Then you ask yourself, can I simplify? If you can, if the answer is yes, then you go ahead and do so. So I'm going to take the same problem and I'm just going to set it up a little bit differently, and you can decide if you like this better or if you like the horizontal way better. So I'm going to do the vertical way. Now the vertical way is kind of how I learned as a kid, and maybe that's how you learn. So I want to just kind of circle back to that. Maybe it'll resonate with you more. So if I set it up like this, you might find this a little bit more familiar. Does that look familiar to you guys? Maybe? Okay. So first thing I'm going to do is I'm going to find my LCM, which we already decided was 12, right? I'm going to convert. How did I get from 4 to 12? Well, I multiplied by 3. Multiplied 3. So this is a 9. How did I get from 12 to 12? Well, I multiplied by 1. Multiplied by 1. This is a 5. Whole numbers don't change. Just move them all on over. And so now you're left with 3 and 9/12 plus 2 and 5/12. So you go ahead and add the whole numbers. 3 plus 2 is 5. 9 plus 5 is 14 over 12. And then at this point, we're going to do the same exact thing. We have an improper fraction, so we need to divide it out. 12 goes into 14 once. 12 times 1 is 12. 2 left over. Ice cream cone. 1 and 2/12. But remember, we still have this 5 here, right? Can't forget about that. So we're going to add 5 plus 1 and 2/12. So 5 plus 1 is 6 and 2/12. Okay, then we need to ask ourselves again, can we simplify 2/12? Absolutely. And that's a question you always have to, that's an ongoing question. Can I simplify? Can I simplify? That's every time you do fraction work, that's going to be a constant question for you. So divide by 2, and we get 6 and 1/6. Okay, so this is just another way to kind of set it up. Either way works. Either way will give you the answer. I just wanted to show you both ways. So give it a shot on your homework, and then any questions you have, bring to our live class, and we will discuss. All right, talk to you soon. Bye-bye.